Okay, our last video here for your final exam review is knowing the graphs. Okay, so you have 8 graphs that you have to be able to write an equation for. Okay, and it's not a hard thing to do if you know some things about your graphs. So let's talk about the difference between a sine and a cosine graph. So a sine graph, you should know, starts at the origin because the sine of 0, 0 degrees, 0 radians is 0. So the sine of 0 degrees, the sine of 0 radians is 0, so it starts at the origin, and it has a standard period of 2 pi. Now remember, a period is the length of time, right, quote unquote time, that it takes for the graph to make one complete revolution. So a sine needs to go up to a max, back to a 0, down to a min, and then back to your max. And that is one complete cycle, right? This is one period for your sine graph from 0 to 2 pi. It, of course, continues on forever, doing this same pattern over and over and over and over. But we're just going to talk about one period. Sine starts at 0 and then goes up to its max first. Cosine, on the other hand, starts at a maximum value. In this case, usually 1, because the cosine of 0 is 1. Right? That's the coordinate, 1, 0 on your unit circle. Cosine is 1, sine is 0. So cosine has the same period of 2 pi, but cosine's graph looks a little different. Cosine has a 0 at pi over 2, and then a minimum there at pi negative 1, and then another 0 at 3 pi over 2, and then the max again at 2 pi. And it continues on forever and ever and ever also. So a sine graph starts at a maximum, or if it was a negative, it would start at a minimum, where cosine always starts at the origin. So that's how you can tell the difference between a sine graph and a cosine graph, is where does it start at your midline. Okay, cosine, sine has a 0 at your midline. Cosine, has a max or a minimum if it's a negative. So if it starts at the bottom and goes up, then it's a negative cosine graph. And if it starts at a 0 and goes down, it's a negative sine graph. Okay, so how about their reciprocals? Let's look at their reciprocals for a second. Secant and cosecant. So first, let's start with cosecant. So the cosecant is the reciprocal of the sine, which means everywhere sine is 0, the graph is going to have an asymptote, because you can't have a y value if the x value is undefined. Right? So if we have 0 in the denominator, that means we have an asymptote. So cosecant has an asymptote at the origin, because that's where sine is 0. Cosecant has an asymptote at pi, because that's where sine is 0. Cosecant has an asymptote at 2 pi, that's where sine is 0. So everywhere sine is 0, cosecant has an asymptote. So these reciprocal graphs, they all have asymptotes. Now, cosine goes up to a max and then down to a min. So the cosecant graph has a parabola-looking thing that goes up from the max and a parabola-looking thing that goes down from the min. Okay, so this is how we know it is a cosecant graph, basically because it has a asymptote through the origin, or the y-axis, because that's where sine is 0 at the origin or at the y-axis. So cosecant graphs have asymptotes at the origin, okay, and all the values of pi. Let's look at his buddy, the secant. The secant is the reciprocal of the cosine. So everywhere cosine is 0, our graph is going to have an asymptote. So just like we talked about, cosine starts at a max and it ends at a max, and it has 2 zeros in the middle. So secant has an asymptote at pi over 2, because that's where cosine is 0. Secant has an asymptote at 3 pi over 2. That's where cosine is 0. So the graph of the secant has a parabola that is on the y-axis, because the sine, the cosine has a positive or a positive 1, a maximum on the y-axis. So if your graph has a parabola, I know it's not a parabola, but if it has a u on the y-axis, it has to be a secant graph. This is a secant graph. Okay. If your graph has an asymptote on the y-axis, then you have a cosecant graph. Right? So some things that you need to know about these graphs. Some attributes that you should know. Okay, so secant and cosecant. These both, by the way, have a period of 2 pi, just like sine and cosine have a period of 2 pi. So it needs to have a complete u going up and a complete u going down in order for it to have one period. So the period for sine, cosine, secant, and cosecant are all 2 pi. Okay, so that's your sine, cosine, secant, and your cosecant. So then what about our two oddballs, tan and cotan? Well, tan is a ratio of the sine over the cosine. So once again, just like secant, everywhere cosine is 0, tangent will have an asymptote. So at pi over 2 and at 3 pi over 2, just like the secant did, the tangent is going to have an asymptote. So we'll put those asymptotes in there. Notice there's not an asymptote at the origin. That's because the tangent goes through the origin, and it is always growing from left to right. So if your graph goes through the origin and is growing from left to right, then you have yourself a tangent graph. More often than not, we're going to have a tan and not some type of a cotan reciprocal or whatever. So our tangent graph goes through the origin, and it has a period of pi. So tangent only needs 1/2 of a revolution in order to get all of its y values. The tangent and the cotan both have a period of just 1 pi. Half of the circle is all it takes for the tangent to get all of its possible y values. Okay? So the period for tan is pi. That's the standard period for tan. Okay? So let's look at his buddy, cotan. Cotan is the reciprocal of the tan, which is cosine over sine. So everywhere sine is 0, we're going to have an asymptote for cotangent. Sine is 0 at the origin, so we have an asymptote going through the origin. Sine is 0 at pi, so we have an asymptote at pi, and sine is 0 at 2 pi. Okay, so it crosses in the middle of all these, just like always, but cotan is always shrinking from left to right. So this is a graph of cotan. So if it looks like it's becoming negative, right, the values are getting more and more negative from left to right, the graph is going down, that is a cotangent graph. Okay, so you need to be able to look at a graph and tell basically whether it's a tan or a cotan. And you do that by looking at its asymptotes. Does it have an asymptote that goes through the origin? If it does, that's a cotan graph. Is the graph have a 0 at the origin? That's a tan graph. Is the graph growing from left to right? Right, the y values are increasing from left to right. That's a tan graph. Is the y values getting smaller, more negative from left to right? That's a cotan graph. Okay, so those are the things that you need to be able to recognize when you see these trig graphs, to discern them from sine or a cosine, cosecant or a secant, and a tan or a cotan. So hopefully you've written some things down and you will become more familiar with these graphs. All right, goodbye. Sorry, hello again. Let's talk about the polars real quick. Our polar graphs. We didn't have very many of them, but let's talk about. So number one, polars have r equals as their equations. Okay, that's number one difference between a polar and a trigonometry. R equals, and it has a theta. Let's talk about maybe like 4 sine theta. Okay, we need to know this is a circle that is centered along the positive y-axis, where this number right here is the diameter. This is the diameter of your circle. Okay, so this is a graph of a polar circle. Right? If it were a cosine, a positive cosine, it would be centered along the positive x-axis. Negative cosine would be along the negative x-axis. Negative sine would be along the negative y-axis. Okay, that's all the negatives tell you about these polars. Okay, if we had r equals 5 sine of 3 theta, right? So now, because it has a number in front of theta, this is going to be a rose graph with a certain amount of petals. Okay, so these have petals. This rose graph would actually start here at 30 degrees, right? And its petals would do something like this. So there'd be a petal here, and then a petal at 120, and then a petal at 240. So 5 tells you that the radius would be 5 units. So this would be along the fifth of our polar circles. Okay, once again, r equals. So if there's a number in front of theta, now we have ourselves a rose. And then the last type of polar that we talked about were limicons. And if you have a smaller number, if the b value is greater than the a, right, the number close to cosine, then we have yourself an inner loop. Okay, so we had all these different things to look at, our inner loop. And we added 6 plus 2 is 8. So your outer radius for your loop is going to be 8. And 6 minus 2 is 4. The inner loop is going to be 4. Okay, and it's going to cross at 2 on your x or your y-axis because of this number, right? That was your non-intercept over there. So we're going to have an inner loop of 4 and an outer loop of 8. So just know that whenever you have the larger number as your b value, that you have an inner loop. And if it's switched, then you have a limicon with dimples. Okay, so you only have an inner loop if this number is bigger. If not, it looks like a dimple. It won't have the loop part. Once again, a positive cosine is the positive x-axis. Had this been a minus right here, it would have gone left with still an 8 and a 4 as your radius. Okay, that's not a negative. This just tells you the direction that your graph is opening, either left, right, up, or down. There, now that's all the graphs we've talked about this semester. Trigonometry graphs and polar graphs. Polar graphs all have r equals. They all have an r equals. That's how you'll be able to tell.